Okay, for this lesson, again, you are stuck with me writing with my finger. However, due to an oversight, I had posted 6.5's lesson instead of 6.4, so we did them in the wrong order. It did not cause any problems because the two have isolated concepts, and in fact, it might have worked to our advantage because when Miss Hurley was in helping with some of the technology troubles we were having, she gave me a little clue that I will include in this recording. So in 6.4, we are again revisited by absolute value. Haven't seen that for a couple chapters now. We're going to talk about it when we're solving equations and inequalities, so both concepts together. So first one, you can solve some absolute value equations using mental math. And this is when we're making a good estimate and checking it. This helps us understand some of the rules for this. So for instance, back in lesson 2.1, that was quite a while ago, chapter 2, the equation absolute value, remember the bars here means absolute value. The absolute value of x equals 8. That means that x could be 8, 8 would equal 8, or it also could be, and it could be negative 8, because if negative 8 was in the absolute value bars, absolute value changes that to a positive number, because absolute value just means how many jumps away from 0 that value would be. And so it doesn't matter, it's not asking you which way, so you do not have to put the integer as a negative or a positive. So with that little review here, it says to solve absolute value equations, you can use the fact that the expression inside the absolute value symbols can either be positive, I'm going to highlight this whole thing, expression inside the absolute value symbols can either be positive or negative, as we talked about up here in this example. So let's go ahead and put this to use because sometimes just the rules makes it hard for us to understand. So here we have an equation, but we are using the absolute value bars with that equation. So the first thing that I want to do is make this into that it could have two different answers. So I could say that the absolute value of x minus 2, so I could say um, this quantity here is going to be positive. And since I'm using my lovely finger here, we're going to just use this symbol, okay? Um, and that could also be that the value inside the absolute value bars, x minus 2 again, it could also be is negative. So we need to solve this in two different ways. So if we said that x minus 2 is equal to a positive 5, this would be our sentence. Very simple sentence. We probably could do this mentally, but I'll just show the work. We would get our like terms, constant terms together. Whoops. We would end up with x on the left of the equation. Notice these are equations, not inequalities. And 5 plus 2 equals 7. Now over here I said the quantity x minus 2 is going to be negative. So I'm going to again write my x minus 2. But as stated up here in our original, I'm going to say this time it's equal, and I said it's going to be a negative, to a negative 5. Same process. Again, this is probably mental because it's a simple equation, but we want to do the explaining. So this would leave me x equals, and a negative 5 combined with a positive 2 is a negative 3. So the equation has two answers. The two solutions would be that x is equal to 7 and -3. Two answers due to that absolute value symbol. Again, if we look back here, we have two answers as well due to an absolute value sign. This one's regarding just the variable, but it's also true for in an equation. These are equations. These are equal to. We have two different answers due to the absolute value symbol. Now, we could go ahead and check those by saying 7 minus 2 would be 5. The absolute value of a positive number stays positive, so is 5 equal to 5? Yes. We'll do this one. -3, so -3 minus 2 would equal -5, a negative and a negative. But the absolute value of that would change to +5. So yes, those are both true solutions. Moving along, we're going to do a two-step equation here. The same rules apply. I will remind us before we get started in solving that because it's an equation involving absolute value, 2x minus 7 could be positive. Same thing I did on the last screen. Or the quantity of 2x minus 7 could be a negative. If we do it first with the positive, we're going to go ahead and now I'm going to the actual solution here. I'm going to do my 2x minus 7 minus 5 equals 4. Now, because there's absolute value here before, I'm going to put this in parentheses 1 minute because it's that quantity. Could be positive or it could be negative. So when I'm combining like terms, I won't be able to take any part of this out yet. So I'm going to instead combine my like terms. So I'm going to add 5 to both sides. So now I have my quantity again, 2x minus 7, and that is going to equal 9. And on this side, I said it was going to be a positive 9. Now this looks very similar to what we started out, an equation and one constant term in example 1. An equation and one constant term. I want to show you what it would do with the negative before we complete this. So in this case, I again would do this first step. I said the quantity of 2x minus 7 could be negative, but I'm copying down the entire equation here, and the entire equation is like this. I will combine my like terms, same as I did on the other side, because remember it's going to have two solutions. Brings me to the same point as I was here. However, my quantity, 2x minus 7, which is left on the left side, is now going to be negative. So that would be if I would do a -4 and a -5, because the right side is going to be negative, as my rule is, I would end up with a -9. Okay? Or you could just stay with this and change your answer to a negative, as we did on this first one. Okay? The 5 was positive, the 5 was a negative. The 4 is a positive, the 4 is a negative. Okay? In doing so, I'm sorry, the 9 is a positive, the 9 is a negative. Sorry, I went up here. Now we are the same as example 1, like terms together, adding 7, adding 7. On this equation, I have 2x equals 16. Divide both sides by 2. I would get x could equal 8 if the quantity started out as a positive. And this equation here, I am going to add 7 to both sides, same as the one on the left. But because my answers are negative, I'm going to end up with 2x equals negative 9 combined with a positive 7 would give me a negative 2. Same process as we've been practicing, same algebra process. X equals a negative 2 divided by 2 would give me a negative 1. So again, I can have two answers to an equation dealing with absolute values. Again, this is equations. These are all dealing with equal signs.